formula for determining amp draw using meter rotation is amp draw equals revolutions per minute times multiplied divided by volts. Let's break down each component of this formula. Firstly, revolutions per minute, often abbreviated as RPM, refers to the number of complete rotations the meter disc makes in 1 minute. This measurement indicates how quickly energy is being consumed. Secondly, the multiplier is a constant value specific to the electrical meter being used. This value is provided by the meter manufacturer and accounts for the meter's internal gearing and calibration. It essentially scales the RPM value to a more meaningful representation of energy consumption. Finally, volts represents the voltage of the electrical circuit being measured. This is the electrical potential difference driving the current through the circuit. Now let's look at an example. Imagine a meter disc is rotating at 1200 RPM. The meter manufacturer provides a multiplier of 1.2. The voltage of the circuit is 240 volts. Using the formula, amp draw equals 1200 times 1.2 divided by 240. This simplifies to 1440 divided by 240, which equals 6 amps. Therefore, the amp draw in this scenario is 6 amps. Understanding this formula allows for estimations of electrical load without directly using a clamp meter, which can be useful in situations where access is limited or inconvenient. When applying this formula in real-world situations, it's crucial to ensure accurate measurements of each variable. Firstly, accurately determining the revolutions per minute of the meter disc is essential. This might involve using a stopwatch and counting the number of rotations over a specific time period, then converting this value to revolutions per minute. Secondly, the correct multiplier value for the specific meter being used must be obtained. This information is typically found on the meter itself or in the meter's documentation. Using an incorrect multiplier will lead to inaccurate amp draw calculations. Finally, the voltage of the circuit must be accurately measured using a voltmeter. Variations in voltage can affect the amp draw calculation, so it's important to obtain a reliable voltage reading. Furthermore, it's important to consider the limitations of this method. Firstly, the formula provides an estimated amp draw based on the average meter rotation speed over a given period. It doesn't capture instantaneous fluctuations in amp draw due to changing loads. Secondly, the accuracy of the calculation depends on the accuracy of the measurements and the correctness of the multiplier value. Any errors in these inputs will propagate through the calculation and affect the final result. Thirdly, this method is most suitable for relatively stable loads where the meter rotation speed is relatively constant. For highly variable loads, the meter rotation speed may fluctuate significantly, making it difficult to obtain an accurate average RPM value. Additionally, it is important to understand the relationship between amp draw, voltage, and power. Power, measured in watts, is the product of voltage and amp draw in a direct current circuit. In an alternating current circuit, power is calculated as voltage times amp draw times the power factor. The power factor represents the efficiency of the electrical system and is typically less than 1. Understanding these relationships can provide a more comprehensive understanding of electrical energy consumption. When dealing with electrical measurements and calculations, safety is paramount. Firstly, always de-energize circuits before working on them whenever possible. Secondly, use appropriate personal protective equipment such as insulated gloves and safety glasses to protect against electrical shock and other hazards. Thirdly, follow all applicable electrical codes and regulations to ensure safe and compliant installations. When measuring voltage, use a properly rated voltmeter and follow the manufacturer's instructions carefully. Ensure that the voltmeter is set to the correct voltage range and that the probes are properly connected to the circuit. When measuring amp draw using a clamp meter, ensure that the meter is properly rated for the current being measured and that the clamp is securely closed around the conductor. Never attempt to measure amp draw by directly inserting the meter into the circuit, as this can create a dangerous short circuit. When working with electrical meters, be aware of the potential hazards associated with high voltages and currents. Never tamper with or attempt to repair an electrical meter unless you are a qualified electrician. If you suspect that an electrical meter is malfunctioning, contact the utility company for assistance. The electrical safety should always be a top priority when working with electricity. To further elaborate on the multiplier, it is derived from the meter constant kh, which represents the number of watt-hours per disk revolution. The multiplier takes into account the potential transformer and current transformer ratios, if any, that are connected to the meter. These transformers are used to step down high voltages and currents to levels that can be safely measured by the meter. The formula amp draw equals revolutions per minute times multiplier divided by volts provides a valuable tool for estimating electrical load in various situations. By understanding the principles behind the formula and following proper safety precautions, you can effectively assess energy consumption and identify potential energy-saving opportunities. Firstly, by monitoring amp draw over time, you can identify periods of high energy usage and investigate the causes. Secondly, you can compare amp draw measurements with expected values to identify potential equipment malfunctions or inefficiencies. Thirdly, you can use amp draw data to optimize energy usage and reduce energy costs. Electrical calculations are governed by various codes and standards such as the National Electrical Code, or NEC, in the United States. The NEC provides guidelines for safe and compliant electrical installations, including requirements for conductor sizing, overcurrent protection, and grounding. It's important to be familiar with the applicable electrical codes and standards in your area to ensure that electrical work is performed safely and correctly. The NEC contains numerous tables and examples that can be helpful in performing electrical calculations. For example, NEC Table 310.15b16 provides ampacity ratings for various conductor sizes based on insulation type and ambient temperature. NEC Article 220 provides guidelines for calculating branch circuit, feeder, and service loads. NEC Article 250 provides requirements for grounding and bonding electrical systems. When performing electrical calculations, it's important to use the correct units of measurement and to pay attention to detail. Errors in calculations can have significant consequences, potentially leading to unsafe installations or equipment malfunctions. It's always a good idea to double-check your calculations and to consult with a qualified electrician if you have any doubts. Furthermore, understanding the power factor is crucial for accurate power calculations in alternating current circuits. The power factor represents the phase difference between voltage and current and ranges from 0 to 1. A power factor of 1 indicates that voltage and current are in phase, while power factor less than 1 indicates that voltage and current are out of phase. A lower power factor means that more current is required to deliver the same amount of power, leading to increased energy losses and higher utility bills. Power factor correction techniques can be used to improve the power factor and reduce energy costs. These techniques typically involve adding capacitors to the electrical system to compensate for the inductive loads that cause the phase difference between voltage and current. The size and placement of the capacitors must be carefully calculated to achieve the desired power factor correction. Power factor correction can provide significant energy savings in industrial and commercial facilities with large inductive loads. In summary, the formula amp draw equals revolutions per minute times multiplier divided by volts provides a practical method for estimating electrical load. By accurately measuring the RPM, multiplier, and volts, and by following proper safety precautions, you can effectively assess energy consumption and identify potential energy-saving opportunities. The electrical safety, adherence to codes and standards, and understanding the power factor are all essential aspects of working with electricity.